The basics of an analytical model compose of a few different ideas which we'll discuss in this video. So there are different components of an analytical model, at least with respect to business decision making. In regards to an analytical model, the first thing that we want to do is characterize certain things about the environment that do not change. So change over time, that is. And so or let me take a step back, with respect to my decision. For example, the price of a product. If I've already set the price of a product and I'm trying to figure out or design a model to determine how many products should I manufacture, it's assumed that the price per product would be fixed. So the first thing when constructing an analytical model is to understand that certain quantities are constant. That is, they don't change. However, we do represent these with variables. So I might say, for example, let P denote price per product. With that stated, when we go and construct an analytical model, we always first try to figure out what's fixed, or what are we going to assume that's fixed? What's not going to change with our decisions or over time in this environment? The next thing we want to identify is a different set of variables, which are referred to as decision variables. These are quantities which do change over time. Usually, we consider these types of variables to be controllable. That is, we're the ones who are turning the knobs, so to speak, in the environment. For example, how many products should we order? What should be, in some cases, what should the price of the product be? What will be the which truck route should I take? Which trucks should I use? When should I dispatch each truck? These are all decisions that I control in the environment. Unlike the constants where we don't control them, or we assume rather they're fixed. The next part, of course, and this is the goal, right? In my environment, I have things that are constant and things that I control. The question is, what should the settings be on the controls? Put differently, which values should be assigned to the decision variables, assuming other values have been assigned to constants? And the way that we judge whether or not our assignment, or more practically our decision, is a good or bad decision is through the use of what's called an objective function. So the thing that you have to recognize in business is that decision making is entirely subjective on the goal of the decision maker. Some decision makers would much prefer to focus on profit, while others would prefer to focus on risk or cost or market share or number of employees or etc. In other words, when I make a decision and actually implement it into the real world, it's having an impact in some manner on the environment. The question is, as the analyst, what is my decision to, or what is my objective to make decision making? Am I going to choose the best number of products to order based on lowest cost, or highest profit, or total market share, etc. So as you can see, when we design an analytical model, it's in part highly dependent on the decision maker themselves. What's their objective? What are they trying to achieve to understand whether or not the decision they made was good or bad? So the objective function is kind of like a scoring metric. How can I know whether or not the decision was a good decision or a bad decision? Well, we need a mathematical function, f, with all of the decision variables thrown in as input so that we can measure or score how good or bad those decisions are. However, one thing we have to recognize is that not all inputs are possible in the real world. For example, if I said, let Q be my decision variable of how much to order, and let F of Q represent the total cost of ordering that many units and holding them for the week while simultaneously selling them at a fixed constant rate, then a question becomes, what is the possible values of Q? Mathematically, the function I have defined may allow for negative quantities, but this doesn't make much sense. So I may, in the real world, what I may do is say, not only do I want to figure out what's my best Q such that my F is at its highest or lowest points, but I may want to do so such that this is also true, because this is more reflective of the real world. I can't order negative quantities. That doesn't make quite much intuitive sense. Furthermore, I may know that my supplier only has a certain capacity, and therefore I would say that Q is a variable which can only be chosen between the quantities 0 and C. Put differently, it's impossible for me to have a Q that's negative or bigger than C. If the Q lies in here, then the possible assignment to Q is what we refer to as a feasible solution. Any assignments that break or we plug into Q and the corresponding statement we made about Q is false, we call those infeasible. Here and here. So what's the name of the game here? The name of the game is to figure out what value should I assign to Q in the presence of constants such that I'm able to minimize or maximize my objective function, and the only possible values I can pick needs to be such that for every statement that I make, that statement holds true. All of those statements hold true about the Q I have chosen. These statements are what we refer to as constraints. So constraints allow us the ability, as the name suggests, to constrain the possible values we can assign to the decision variables. And next and last, what we want to understand is what's the best solution, meaning minimum or maximum. And that best solution is what we refer to as an optimal solution. There could very well exist multiple optimal solutions, not just one. Depends on the application you're looking at. But the moral of the story is that when we construct an analytical model, we start by first assuming things about the theoretical world that are derived from the real world. We identify which quantities in our model that we want to remain fixed and which ones will be subject to change by the decision maker or change over time in some fashion. We then need to score how good or bad our decisions are by the use of an objective function. Once we have that, Then we can put on constraints that say we want to find the best input to give us the best output. However, we want to do that with only a limited range on the input. That limited range, or possible quantities for which we can assign to Q, are referred to as constraints.